Hello friends. In the previous lecture, we have seen the Laplace transform of derivatives. So now we will discuss about the Laplace transforms of integrals. So here the statement is, if L of f of t, that is the Laplace transform of f of t equal to f of s, then Laplace transform of integration between 0 to t f of u du, that is equal to 1 divided by s f of s. So in this particular case of Laplace transform of integrals, so here the function will not be expressed with the variable t, rather we will be introducing the new variable as u. So henceforth, if each function in this particular type will be expressed with the help of the new variable u, and the limit of integration will be between 0 to t. And this, since the function is expressed with the variable u, it has to be integrated with respect to u. So again, we have the first problem. As I told you, proof we will not be discussing. Directly we will be talking about the problems. Find the Laplace transform of first one, integration between 0 to t u cos h of u du. Or sometimes it may also be asked in this form, find Laplace of integration between 0 to t u cos h of u du. Okay, so the first we will start with the cos h of u. So here we have a function f of u as cos h of u. Let f of u equal to cos h of u. Then we will find the Laplace transform, and Laplace transform of cos h of u. We know that is Laplace of cos h of u as s divided by s square minus 1, since it is an hyperbolic function. So after cos h of u, okay, so we have done with a cos h of u. Then we have the next function as u. And since u and cos h of u, they have appeared as a product of two functions, it resembles like a standard form of effect of multiplication by t. But here it is not t, it is with respect to u. So we will apply the same formula here. Laplace of u cos h of u, that is equal to, the power of u is 1. So it is minus 1 raised to 1 d by ds s divided by s square minus 1. Okay. So further, it is minus 1. Since it is s divided by s square minus 1, we can have the u by v form, the quotient rule of derivative. And we have this particular form, that is s square minus 1 whole square. The square of the denominator, the same function will be shifted to the numerator. The derivative of s equal to 1. Again s, the derivative of s square minus 1, which is to be 2s. And further, we may have minus 1 s square minus 1 minus 2s square divided by s square minus 1 whole square. Okay. So here, after that, we need to simplify them, and this is a simplification, that is minus 1 minus s square minus 1 divided by s square minus 1 the whole square. And the next possibility would be taking this negative sign as a common factor, which gets multiplied here. It becomes a plus. So finally, we will have s square plus 1 divided by s square minus 1 the whole square, that is to be considered as f of s. And since after cos h of u and u, we have the next term as integration sign. And the moment when you that is introduce the integral sign on the left hand side, on the right hand side, this f of s, whatever the f of s term or the functions are there, that entire function needs to be multiplied with 1 by s as per the standard statement. So here, since Laplace of cos u cos h of u is s square plus 1 divided by s square minus 1 the whole square. So now we will introduce on the left hand side that limit of integration between 0 to t u cos h of u du, and this function we are finding the Laplace transform, that is same as this f of s to be multiplied with 1 by s. So 1 by s with this f of s. And okay, now in the second problem, we have finding the Laplace transform of 0 to t e to the power of minus 2u cos square of u. Let's start with the f of u. So here f of u is a cos square of u. So then cos square of u can be expressed as 1 plus cos of 2u divided by 2, as we cannot find the Laplace transform of cos square of u. Then we will have 1 by 2 1 plus cos of 2u as an equivalent statement. Then Laplace of cos square of u as a 1 by 2 Laplace of 1 plus cos of 2u. So Laplace of 1 as a 1 by s, and cos of 2u s divided by s square plus 4. So here 1 by 2, 1 by s plus s divided by s square plus 4. So after cos square of u, we will have the next term as e to the power of minus 2u. So here we will have Laplace of e to the power of minus 2u cos square of u. So it resembles like the standard form of first shifting property, e to the power of minus et into f of t. So whatever f of t, the function Laplace transformation is there, that is f of s, that s to be replaced by s plus 2 by using fst. So that is 1 by 2, 1 by s plus s divided by s square plus 4, and wherever s is there, that each s to be replaced by s plus 2 by using fst. So accordingly, we may change s as s plus 2, and then on simplification, we obtain 1 by 2, 1 divided by s plus 2 plus s plus 2 divided by s square plus 4s plus 8. So here, now we have seen cos square of u was included, e to the power of minus 2u is included. So according to the question, now we need to introduce integration between 0 to t. And the moment when we introduce integration between 0 to t on the left hand side, the entire right hand side expression should be multiplied with 1 by s. So therefore, we will have Laplace of integration between 0 to t e to the power of minus 2u cos square of u du. So the first term is multiplied with 1 by s. So it is 1 divided by 2s, s plus 2. The same with the second. It has been multiplied with a 1 by s. This is about the final answer. So now in the problem number 3, we use the Laplace transform to evaluate this given function, which is 0 to infinity e to the power of minus t, 0 to t sine of u divided by u du dt. So let's begin with the sine of u. So we have Laplace of sine of u as a 1 divided by s square plus 1. Then after sine of u, then sine of u divided by u. So we will have Laplace of sine of u divided by u as integration between s to infinity 1 divided by s square plus 1 ds. And further on integration, we know that this function gives tan inverse of s. So here we have tan inverse of s, lower limit as s and upper limit as infinity. And then on substitution, we will obtain tan inverse of infinity minus tan inverse of s. And tan inverse of infinity is pi by 2. So directly we will write here as a pi by 2 minus tan inverse of s, and that gives cot inverse of s. So we obtain Laplace of sine of u divided by u as a cot inverse of s. And according to the question, after sine of u divided by u, it should be integration between 0 to t. So we will introduce that. Here Laplace of integration between 0 to t sine of u divided by u du, that is equal to this cot inverse of s must be multiplied with a 1 by s. So here it is 1 by s cot inverse of s. Then we'll make use of the definition of Laplace transform. By using the definition of Laplace transform, and if I consider this function, entire function as a f of t, okay, just for the reference, then we will have integration between 0 to infinity e to the power of minus st, and this function as usual integration between 0 to t sine of u divided by u du dt, that is equal to 1 by s cot inverse of s. But in the question here, it comes with a 0 to infinity and e to the power of minus t. So for that, we will substitute s equal to 1. So for s equal to 1, we obtain the result as integration between 0 to infinity e to the power of minus t, 0 to t sine of u divided by u du dt, 1 by s, that is 1 by 1, which is 1, cot inverse of s as a cot inverse of 1, which is pi by 4. So finally, we will have the result as integration between 0 to infinity e to the power of minus t, integration between 0 to t sine of u divided by u du dt, that is equal to pi by 4. So these are the three problems under Laplace transform of integrals. So for more problems, you may refer to the link provided in the description. And for any doubt or query, please comment, and don't forget to subscribe, share and like the video. Thank you.